Okay, so this is the second part of the Pilot 6 demonstration. So I'm Richard McCready from the University of Glasgow, and I'm going to be talking a bit more about some services that were developed during the first reporting period for Pilot 6 as part of Infinitec, and also demonstrate those services within a prototype UI. So, as we noted previously, Pilot 6 builds on a range of different Infinitec services and technologies as part of the reference architecture, and also contributes to that reference architecture. So probably the core technology that we use here is the InfiniStore, because we use that both for secure data storage for our customer and our transactional and our asset data. And we also need that for fast retrieval of that data to serve customers in real time. And we're also going to be building more on that in terms of the real-time analytics technologies in period 2. The other main technology or building block of the Infinitec reference architecture that we use as part of Pilot 6 is we're a contributor to the machine learning and deep learning library as part of Infinitec, where we are contributing both customer risk profiling components as well as a financial recommender framework as well, which are used for effectively better understanding customers and being able to recommend assets to those customers. And it's those technologies that we built a first version of during the first reporting period, starting with the customer risk profiler. So if we think about it, our end goal for this pilot is to effectively provide a system to the financial advisor that can recommend financial assets or asset groups to an individual customer that advisor is sitting in front of, or maybe is on a network call with. And so one of the key things that we need to be able to understand about a customer is how risk averse or risk seeking that customer is. Because if you think about the particular people that might be investing, then they exist on this scale where you have sort of very risk averse customers who want to invest and get some money, but they are very averse to the potential of losing money. Whereas you also might have very risk seeking customers who are interested in taking on more risk for a greater reward. And so you need to understand where in that spectrum a particular customer exists. And so the customer risk profiler aims to go and provide some automatic prediction of that based on the customer's past history. In particular, we're leveraging information about their past transactional data. So this is deposit account transactions and credit card transactions. We maybe have information about their demographics. And also, if they've invested in the past, we also have that information as well. And so during period 1, a number of models were developed to basically automatically categorize the customer into these different risk categories. So from conservative to aggressive. And then that feeds a downstream component, which is the financial asset recommender. So the idea here is this is actually our endpoint system that is going to, for a particular customer, recommend or rank assets or asset groups for that particular customer. So the idea here is we treat this as a supervised asset recommendation problem, where we want to rank assets or asset groups for the particular customer based on their past history, their profile, including the risk estimation that we have from the previous component, and also the assets information. So its cost, its predicted profitability and risk. And so what we've done during period 1 is we've treated this as a supervised asset recommendation problem where we're using state-of-the-art deep learning technologies, which we're extending from an existing framework called Beta-Rexis that we developed as part of a previous Horizon 2020 project. And for Infinitec, we're extending this to tackle the challenges of the financial domain. During period 1, we developed 3 different types of models, from collaborative filtering to hybrid models. And so far, we've developed and tested 9 different models. We've also performed evaluation of these models, which I'll just give you a flavor of here. Because, of course, what we're really looking for is we're looking to find the best quality model so we could actually put that in production in the National Bank of Greece. So there are 2 different ways that you can evaluate the quality of asset recommendations to customers. The first one is you can use past investments to effectively predict whether or not you are reproducing or closely matching what customers actually do in terms of their investments. So what we did was initially we took we trained our models based on financial asset and transaction data from 2018 to August 2020, and then we test this on transactions from September 2020 to December 2020, where the models are going to rank, well, in this case, asset groups per each individual customer. And what we're looking at for evaluation is in terms of this September to December period, for customers that invested during that period, are we recommending the same assets that they actually invested in? And so these are the results. Let me just hide my head here. And so what this graph shows is this shows the ranking performance under the NDCG metric at rank 3, so effectively the top ranked recommendation or recommended items for our different models, where the first column here is the base collaborative filtering model, where like this is matrix factorization, which is kind of a traditional baseline, and these are more state-of-the-art neural approaches. And then the second bar here is the hybrid equivalent, where you're integrating in content-based features, so more information about assets, effectively. And so what we can see here is that not only are we fairly effective at ranking asset groups, so in terms of NDCG at 3, this indicates that, roughly between maybe 2 to 1 to 2 of these are good assets for this particular customer. And we can also see here that in terms of the different types of models, it's the hybrid neural graph-based approaches that are clearly more effective than traditional models. So we're getting value from these state-of-the-art deep learning models. The second way you can evaluate these types of approaches is based on profitability. So effectively, we have the same setup here, except instead of looking at whether, to what degree are we recommending items that are similar to what the customer would actually invest in, we're instead looking at the profitability of the assets themselves, where we're evaluating average annualized return on investment. So this is effectively a percentage. So how much profit am I going to get if I'm going to invest in these assets that you're recommending to me? And so again, this is a similar same graph with the same models. In this case, what our vertical, our y-axis here, is the annualized returns. This is the percentage profit that you're going to make if you invest. And then this horizontal line here is the average return of the assets in the particular stock market that our assets come from. And so what we can see here is that using these, or in terms of these assets that we're recommending, these are significantly more profitable than the average return on the market. So effectively, these would be good assets to recommend, and people are going to make money from investing in these assets. So to indicate that our models are actually working. Okay, so that's enough about the actual underlying services. So now I'll just quickly illustrate how this would actually be used by a financial advisor. So you can imagine that customers come into the bank, they're sitting in front of their financial advisor, and the financial advisor now wants to get information about that customer and also get some initial assets or asset groups to potentially recommend to that customer for investment. So what they would actually do is when they're sitting down, they would open up their terminal and put in their login details and the customer ID. And then when they hit search here, what happens in the back end is that we're making a very quick request to the Infinity Store to get information about that customer initially. So we see here we've got information about that particular customer in terms of like their financial situation. So their income, their balance over different time periods. We also have information about their investment horizon. So this is how during what time frame are they expecting roughly to get a return on investment. And we also have the risk appetite labels. This is coming from the risk profiler that I talked about previously. We also have information about past investments if they have any. And then the right-hand side here is a rendering of the results from the asset recommendation system for this particular customer given their risk appetite and investment horizon. So what we can see here is that it's grouped, well, we've grouped the assets that are being recommended into different asset groups or categories. So we have mutual funds, government bonds, and also large cap common stocks. And then we can see on the right-hand side here, the scores for those asset groups aggregated across the assets within those groups as provided by the recommendation system. So it thinks that mutual funds are the best type of assets in this case to recommend to the customer. And you can click on this to get more information about the price on investment, expected profit, volatility, and Sharpe ratio, and as well as information about the past history of this particular asset. And this makes sense because for this particular customer, if we look back at their investment history, we can see that they've invested significantly in mutual funds before. So that would make sense that we should recommend them mutual funds. However, we can also see at some of the other assets that were recommended in this case, for example, these government bonds, and the particular financial advisor might say, okay, well, because I can see that this customer is potentially more interested in taking risks, maybe I should look at some of these assets that have a higher return ratio. So effectively, the customer is going to are predicted to make more profit on these particular assets, and recommend those. And so we can see a breakdown of some of these other assets that the customer or the financial advisor might recommend to the customer. And so they can utilize these initial kind of seed recommendations by the system to provide an initial set and get a feeling for what the customer is interested in. Okay, so that's how the recommendation system is envisaged to work with our prototype. During the second period, we're looking to extend some of these models that we've been developing to capture more real-time data, as well as enable us to update this data in real time as the effectively stock market changes from minute to minute. Thanks for listening.